We have here an aquarium filled with lukewarm water, and I also have an ice cube that has been made by taking colored water and freezing that in the freezer overnight. I'm going to place the ice cube now in the center here, and watch what happens now as the ice melts and the food color moves down. You can see the streams of cold water going down to the bottom of the aquarium as the ice cube melts, and the cold water then being more dense than the warm water sinks. It's important when doing this demonstration to make sure that the water stands for a little while so that it's not turbulent when you put the ice cube in. Otherwise, the water will move around. Here's a demonstration to show the density of warm water relative to that of cold water. I have some cold water in this cut-off 2-liter pop bottle. I've got here a film canister with a hole cut in the lid, and I'm adding a weight to it so that it will actually sink. I've put some warm water in the container. Now I'll add some food coloring to it. Put the lid on, and now lower this into the container. And notice how the red coloring moves up as the warm water rises in the cold water. The purpose of putting a weight in the bottom is to make sure that the whole container sinks, because the container by itself has about the same density as the cold water. So we need to increase its mass slightly. Here's another way to demonstrate the same effect. I've got a bottle, small glass bottle, with a string glued on or taped on with some masking tape, and we'll add some food coloring to that. And then I'll use the string to lower the bottle into the pop bottle. And again, you can see the warm water rising because of its coloration and staying near the top of the cold water, as you would expect for the differences in density of cold and warm water.